Okay, I'm going to try to make this fast. I talk slow and I move slow, and I don't think slow, but I do everything else in life slow. So what I'm going to do is talk about, this is going to be pretty dry and boring, by the way. I've compared the operation, the resonant frequency and SWR excursions on this FT120-43 core, both with and without a shunt capacitor on the input on the 50 ohm winding. And so I've done that today, and today I added the 150 picofarad shunt cap. The blue ink is what I found without the cap. I'm going to run through it real quick. Without the cap, you'll see that I used a 4-inch extension to tweak the resonant frequency, which is what I like to do, so that I can achieve optimum SWR, optimum match, at both the CW and up into the phone portion of the bands, even though I rarely work phone. So that's why I like to I tune my antenna for the phone portion of the band and then add a short extension to bring the resonant frequency back down into the CW portion of the band. That's generally what I like to do. And so you can see, let's run through it without the cap. The resonant frequency was at 7113 by adding, and that allowed, at the very top end of the band, I had an excellent match still. By adding the 4-inch extension, I brought the resonant frequency down to 7030, which achieved an excellent match across the whole CW/digital portion of the band. Now then, let's talk about 20 meters. The resonant frequency without the extension was at 14.2, and by adding the extension, I brought the resonant frequency down to 14080, and with a perfect match. On 21 megahertz, without you'll see there's no extension listed here. That's because the resonant frequency on 15 meters was just below the bottom of the band already. So, if I would have added the extension, it would have dragged it down even farther. That said, even though the resonant frequency was just below the bottom of the band, using the 16:1 tap, I achieved an excellent standing wave ratio. And you'll see I noted here at 21,350, the standing wave ratio had only risen to 1.8, which is very acceptable. You wouldn't even really need a tuner. Maybe if you're running 100 watts, your rig might start cranking back a little, but at that point. Okay, onward. On 10 meters, without the cap, no coverage at all. Zippo. Okay, now then, let's talk about the what I found today with the 150 picofarad shunt cap on the input. Let's start with 40 meters. I'm going to reposition things a little bit here. Let's start with 40 meters. What happened was, you'll see, without the cap, the resonant frequency without the cap, without the extension, was at 7113. Added the cap, the resonant frequency dropped to just at the bottom of the band edge, which, using the same tap as before, achieved the same standing wave SWR as before. However, since the resonant frequency had been dragged down to the bottom of the band edge, I could no longer add the extension. I could no longer use the extension to tune the antenna, so, to tweak it. But I did note that at the top of the band edge, by using the 49:1 tap, the standing wave the SWR was 2.4:1. Very acceptable. What would I do? We'll talk about that in a minute. let's go to 20 meters. Now then, you'll see before it was very non-sensitive to frequency excursions, and now that's changed. Now then, with the cap, the resonant frequency is now at 14.1 with a perfect match. At the band bottom, although I didn't note it here, at the band bottom it was 1.5. At the band top it was 1.6, which gives us your typical SWR curve. And that's about perfect. 20 meters is excellent, just as it is, with the wire length as it is. Actually, all the bands are. It's fine. If this were a permanent antenna that I was installing, I wouldn't even bother to change the length of the wire. I'm happy with it just like it is, because I'm a CW op. And even if you're going to operate phone, let's say on 40-meter phone, are you really going to transmit on 7.300? No, you're not. You're probably going to be operating on whatever, 7260 or something, and the standing wave ratio would be significantly lower. There's really no need to change anything here. It's wonderful. So anyway, back to the bands. So on 15 meters with the cap, it resonates at the band bottom. I'm going to drop this down. Sorry about that. It resonates at the bottom of the edge of the band with the 36-to-1 tap. Excellent match. However, on 15 meters with the cap, it's broad banded enough at the top end of the band. Look at that. Standing wave ratio. From edge to edge, 1.2 rises to 1.35. That's crazy. That's excellent. I like it. Okay, now then. Now that we've about beaten this horse to death, which is a pretty crazy, messed up saying. What do they mean by that? Did anybody actually beat their horse to death? I assume they're talking about overworking him. But still, man, that's called animal cruelty, man. We've about exhausted this topic, I believe. That's better. Okay, 28 megahertz, 10 meters. Not operable without the cap. Not operable. Okay, so with the 150 PF shunt cap on the input, what did I find? Unreal. With a 9-to-1 tap, bottom edge of the band, 1.5-to-1. Top edge of the band, 1.3. Somewhere in the middle, 1.1. Right? Excellent. Unbelievably excellent. So I think this answers the question. The question is, do you or don't you use a shunt capacitor on the 50 ohm winding? Well, you don't have to. The thing works great without. Works even greater with. And you got to keep in mind, this is just my results. Results may vary, as they say. This is using no inductive or capacitive tuning on the wire. It's a simple piece of wire. What I like to think of as my garbage picked wire. The only part of the whole system is the core. I guess an alligator clip for the end of your antenna wire. Right? But, one moment. Okay, I had to collect my thoughts there. My blank went brain. So what would I do? What will I do? I will use the cap. I'll tidy it up a little because it's just tacked on there now. And I will be packaging my various size UNUN cores in small packages with banana post jacks and such. So before potting the cores, will I install a cap? Yes, I will. But what I'll do is I'm going to tip you up. What I'll do is readjust the length of the wire. I'll install the cap, and then I'll remove just a little bit of wire. I don't know how much, because I'm just starting to gain experience with end-fed half-wave wires, but it's like any antenna. The lower the frequency, the more you've got to remove to achieve significant change, right? So I'll try, I don't know, 3 inches at a time. I'm gonna whack 3 inches off of this 40 meter end-fed half wave so that I get this. Well, I'm rotating my pointer and you can't even see it. I'm doing this dramatically. I will whack off 4 inches of wire, 3 or 4 inches. I want to get back to this so that I can tweak it for perfect resonance at both the bottom, in both the data CW portion of the band and the phone band portion of the band. So anyway, a whole lot of talking, man, even for me. And I'm not done yet. I'm not done yet either. That was nice. You like that? I could edit that out, but this is raw. This is Detroit style YouTubing, man. Even though I'm not from Detroit, I wasn't born in Detroit. I worked in Detroit for decades. That gives me cred. Okay, sorry about that, man. I did a little bit of UNUN efficiency testing again, using this 40 meter end-fed half-wave wire, 63 feet long exactly, using the FT120-43 core, my tiny core. And the reason why I repeated this test was because now I can transmit on 10 meters. I wanted to see how bad the efficiency of the core, how much power is the core absorbing on 10 meters. So you can see what I did. I transmitted a 25 watt carrier, which is what I consider this core to be rated at. You could operate this core all day long at the 20 watt level using CW 20-25 watts. You can use it all day. You could transmit a carrier all day and all night at the 25 watt level. It'll get a little warm, but it's not going to melt down. Your standing wave ratio is never going to change. The core handles it fine. So at the 25 watt carrier level on 10 meters with a 60 watt carrier, the core got warm, noticeably warm too. Bathwater warm? Yeah, I'd call it bathwater warm after 1 minute of key down 25 watts. Repeating the test for 30 seconds, there is barely noticeable warming. So, what conclusion can you draw from that? Well, I don't know. You can draw the conclusion that on its most inefficient band, 10 meters, where you would expect the core to absorb a lot of your energy, or more energy than it would on 40 meters, for example, it didn't absorb a lot. Is this a scientific test? Well, yes. The more power it absorbs, the warmer it gets, then the more heat I detect with my hand. That's the scientific method, man. Anyway, yeah, this is practical, everyday, subjective, amateur radio, screwing around. 73, man.